All right, so now let's continue our notes from section 4.3, which is applications of systems of linear equations. So now let's start with this example on page 4. It says the fancy French perfume company recently had its secret formula divulged. It turned out that it was using as the three ingredients rose oil, oil of fermented prunes, and alcohol. Moreover, each 22-ounce econo-sized bottle contained 4 more ounces of alcohol than oil of fermented prunes, while the amount of alcohol was equal to the combined volume of the other two ingredients. How much of each ingredient did the company use in an econo-sized bottle? So first we have to write down our unknowns, and then we have to pick apart this problem and figure out what we need. Okay? So again, our question says, how much of each ingredient did the company use in an econo-sized bottle? So what things don't we know? So our unknowns are the number of ounces of rose oil. So we're going to let that be X. So the number of ounces of rose oil. We also do not know the number of ounces of fermented prune oil. So we're going to write this down. And we also don't know the number of ounces of alcohol. Okay, so how can we connect everything that we know into equations? Well, let's take another read. It says, moreover, each 22-ounce econo-sized bottle contained 4 more ounces of alcohol than oil of fermented prunes, while the amount of alcohol was equal to the combined volume of the other two ingredients. So now let's interpret this. What we know is each 22-ounce econo-sized bottle contained all of this. So what we know is that we know that the total amount in a bottle is 22 ounces. So in other words, the equation we get for this is x plus y plus z equals 22. Okay? Now, we also know, that's one thing. We also know that each bottle contained 4 more ounces of alcohol than oil of fermented prunes. So equation-wise, what this means is that z is equal to y plus 4, or if we're putting all the variables on one side, that means that negative y plus z is equal to 4. Okay? And then we have another piece of information. It says that the amount of alcohol was equal to the combined volume of the other two ingredients. So what does that mean? That means that Z, because that's the number of ounces of alcohol, that means Z is equal to X plus Y, or if we move all of the equations to one side, that means we have X plus Y minus Z is equal to 0. So we end up with 3 equations that we need to use here. And it will help us, knowing these equations will actually help us solve the system of equations. So now what we're going to do is use that bit of information. So let's set up our matrix. We need to solve the system. So what we're going to do is take the coefficients of each of these equations and we're going to put them in an augmented matrix form like we have been doing. So solving, we take the coefficients. From the first equation, our first row gives us 1, 1, 1, and 22. Our second row is 0, -1, and then 1 and 4. And then our third row is 1, 1, -1, and 0. Okay, so that gives us our augmented matrix. Now let's row reduce. So making an observation, we already have a 1 here, and we'll use that as our pivot. We have a 0 here. Now let's create a 0 in the 3, 1 position. So in order to do that, we're going to have to change row 3. So we're going to do row 3 minus row 1 to get a new row 3. And we're going to use this 1 as our pivot. So rows 1 and 2 will not change. So we have 1, 1, 1, 22. Then we have 0, -1, 1, and 4. And then if we do row 3 minus row 1, then that's 1 minus 1. That will give us 0. Then we'll do 1 minus 1. That will give us 0. Then we'll do -1 minus 1. That'll give us -2. And then we'll do 0 here, minus 22. So that will give us -22. Okay, so far so good. Now we look at our row 3 and we can see that these two have 2 in common. So let's take this matrix, and this row particularly, we're going to multiply 1/2 times row 3 to get a new row 3. So we're going to do 1/2 times row 3 to get a new row 3. Our matrix, remember rows 1 and 2 aren't changing, so that's 1, 1, 1, 22, 0, -1, 1, and 4. And then we're multiplying row 3 by 1/2, so our row is going to become 0, 0, -1, -11. Okay, now we would like to create a 0 in the 1, 2 position, and we're going to use row 2 to do that. So this -1 here is our pivot, and now what we're going to do, we're changing row 1. So we're going to say row 1 plus row 2, since 1 and -1 are opposites, and then we're going to get a new row 1. This operation gives us the following row. So we're going to have 1 here, and then since 1 plus 0 is 1, then we're going to have 1 plus -1 is going to give us 0 here, so let's write that. And then we're going to have 1 plus 1 gives us 2, so we'll have 2 here, and then we'll have 22 plus 4 gives us 26. So that will be our new row 1. Now rows 2 and 3 stay the same, so you'll have 0, -1, 1, and 4. And then our third row stay the same as well, so we just write that down. Now our matrix is looking good. Now what we need to do, we need to create a 0 in the 1, 3 position, and we need to create a 0 here in the 3, 3 position. So we're going to use, well, not in the 3, 3 position. Let's rewind that. We need to make sure we create a 0 in the 1, 3 position and the 2, 3 position. We're going to use this -1 here as our pivot. Okay, so make sure you understand that. So now this -1 is going to be our pivot, and the operations that we need to do to create zeros in those positions where we see the 2 here and the 1 here. The operations we need to do are row 1 plus 2 row 3 to get a new row 1. Then we're going to do row 2 plus row 3 to get a new row 2. So we'll have our first row is changing. So what we're going to do is we're going to have row 1 plus 2 row 3 to get a new row 1. So we're going to take 2 here plus 2 times -1, and we're going to get a new number here. So let's go ahead and do that. Our row 1 is going to change to 1 plus, we're using 1 plus 2 times 0, we just get 1 here. So we write 1, then we get 0. So we get 0 here, because then we'll have 2 times, let me show you, we'll have 2 times -1 times 2, so that'll give us 0 as well. Then we're going to have 26 plus 2 times -11, so that's 26 minus 22. That's going to give us 4. Our second row is going to change. We're using that -1 here as our pivot. So we're going to have 0 plus 0, we get 0. Then we're going to have -1. We'll have -1 plus 0. That's going to give us -1. Then we'll have 1 minus 1. That'll give us 0. And then we'll have 4 minus 11. That'll give us -7. And then our last row is 0, 0, -1, and -11. So now all we have to do is get rid of the negatives here and here. So to do that, all we need to write is -1 times row 2 to get a new row 2, and then we're going to multiply -1 by row 3 by -1 to get a new row 3. So our matrix is going to be 1, 0, 0, 4. First row didn't change. Then we're multiplying all of the entries in row 2 by -1, so that's going to make them positive. And then similarly with row 3. So what we have is x is equal to 4, y is equal to 7, z is equal to 11, which means each bottle contained 4 ounces of rose petal oil, 7 ounces of oil of fermented prunes. You don't know how that's going to smell. And 11 ounces of alcohol. Okay, so that concludes example 3. All right, so now we're going to move on to example 4, which is investing lesser known stocks. If you have questions about the previous example, write them down and come prepared for class on Thursday to ask questions about these examples. So make sure you pause, go through the process, watch the video over and over again if necessary, and come with questions. Okay, so moving on to example 4, investing lesser known stocks. So here we're given a table, and we have WSR Whitestone REIT at $16 is your price. Dividend yield is 7%. Then you have HCC Insurance Holdings Incorporated, $56 is the price, 2% dividend yield. And then you have SanDisk Corporation, which is SNDK, at $80, which is your price, and then a 2% dividend yield. Okay, so you invested a total of $11,200 in shares of the 3 stocks. at the given prices and expected to earn $304 in annual dividends. If you purchased a total of 250 shares, how many shares of each stock did you purchase? So, because the question is saying how many shares of each stock did you purchase, then what we do not know is the shares of each of these stocks. So we're going to write down variables and we're going to let the number of those stocks be unknown, or number of the shares of each stock be unknown. So the first thing, we write down our unknowns. And we're going to assign variables. So we're going to let X be equal to the number of shares of WSR. We're going to let Y be equal to the number of shares of HCC. And we're going to let Z be equal to the number of shares of SNDK. Okay? Now, we know that the total investment was $11,200. So, we know that the total investment was $11,200. So now we can talk about the investment in WSR at a specific amount. So remember, X is the number of shares of WSR. So when we talk about the investment in WSR, that's going to equal X shares. And if we look back at our table, we're going to see the price was $16. So at $16, which means that's going to be 16x. The investment in HCC is equal to Y shares at how much? If we look back up at our table, we find HCC and we look at the price, it was $56. So we're going to write at $56, which means that's 56Y. And similarly, we can write down the investment in SNDK is equal to Z shares continue, which means this is equal to 80Z, right? Okay, perfect. So what we get from our investment part, the total investment, means that we have the equation 16x plus 56y plus 80z. Since we talked about the investment for each stock, okay, we talking about the shares of each stock, we have all of them is going to equal 11,200. So that's one equation. Now we need to find the others. Okay, so let's do that. Now we can use our dividends. So here we expected to earn $304 in dividends. Now what we're going to do is we're going to talk about each stock and the dividend yield, and we're going to tie that in, okay, with incorporating the percents. So our WSR dividend, that's a V here, a WSR dividend was equal to 7%. We got that from our table. From here, we have our 7% of our 16x, which was invested, which means mathematically that's equal to 0.07 times 16x. Multiply those two, you get 1.12x. Okay? And now we can talk about our HCC dividend. And if you look back up at your table and the dividend yield for HCC, that was 2% of. Now we're talking about our HCC. The investment for our HCC was 56Y. So we're going to use that here. So 2% of 56Y invested is equal to 0.02 times 56Y. That's going to give us 1.12Y. And then our SNDK dividend is equal to 2% of 80Z invested, which equals 0.02 times 80Z, which is equal to 1.6, that's a 1 here, 1.6Z. So what we have now is we expected to earn $304 in dividends. We have the dividend for each one. Now that we add them up, that means that 1.12x plus 1.12y plus 1.6z is going to be equal to 304. That's going to give us our second equation for our system. Okay, now we need to find our last equation. But how do we do that? We have one more piece of information that we didn't use yet. If we purchased a total of 250 shares, that's what we haven't used yet. We haven't used the fact that we're purchasing a total of 250 shares. So that means if we take X, Y, and Z, add them up, equal to 250, that's the last equation. So you purchased, I'll write in red, stay consistent. You purchased 250 total shares, which means X plus Y plus Z is equal to 250. So that's our third equation. So now we're going to take those three equations and we're going to use that as our system, and we'll take the coefficients and use the augmented matrix and we'll solve. So let's write those equations down. We have X plus Y plus Z is equal to 250. We have 16X plus 56Y plus 80Z is equal to 11,200. And then we have 1.12X plus 1.12Y plus 1.6Z is equal to 304. So, putting our augmented matrix together, we have the coefficients. We just write down the coefficient rows. And you have 16, 56, 80, and then 11,200. And then you have 1.12. I'll align this a little bit better. And 1.12. Then you have 1.12 again, 1.6, and 304. Now we can eliminate these decimals in the third row here by multiplying row 3 by 25. So we're going to have 25 times row 3 to get a new row 3. Rows 1 and 2 do not change, so we'll have 1, 1, 1, 250. Then we're going to have 16, 56, 80, and 11,200. Then we're going to have 25 times 1.12 gives us 28. So our first two positions are 28. 25 times 1.6 gives us 40. And 25 times 304 is 7,600. Pause and do those calculations if you need to. Now what we're going to do, we're going to simplify rows 2 and 3 because those are some large numbers. Everything in row 2 has an 8 in common, so we can divide row 2 by 8 or multiply row 2 by 1/8. For this one, they all has 4 in common, so we can multiply row 3 by 1/4. So that's going to be our next step, is to simplify. So, or to do some more row reductions. So what we're going to do is we're going to do 1/8 times row 2 to get a new row 2, and then we're going to do 1/4 times row 3 to get a new row 3. Row 1 is unchanged, so we write 1, 1, 1, 250. Row 2, if we multiply each term there by 1/8, then that reduces to 2, 7, 10, and 1,400. Then row 3, we multiply each coefficient here by 1/4. That will give us 7, 7, 10, and 1,900. Those numbers look a lot better to deal with. So now what we're going to do, we're going to row reduce as we have before. We're going to use this 1 as our pivot, create zeros here and here. So let's do that. We'll do both at once. We need to, and you should try this on your own, and then come back to the video if you can't figure it out. So you have row 2 minus 2 row 1 to get a new row 2, and then you're going to have row 3 minus 7 row 1 to get a new row 3. So again, pause and do those calculations and then come back and check to see if you get the correct thing. So you have 1, 1, 1, 250. Row 1 did not change. Then we're going to do row 2. So that's 2 minus 2 times each enter here. So 2 minus 2 times 1. 2 minus 2 gives us 0. So we created a 0. Then you'll have 7 minus 2 times 1. That'll give you 5. Then you have 10 minus 2 times 1. That'll give you 8. And then you'll have 1,400 minus 2 times 250. That is 500, so that'll give you 900. And then you do row 3 minus 7 times row 1. That will give you a new row 3. That'll give you 0, 0, 3, and 150. Pause if you need to and take your time going through this. Now, we have a 0 here. We need to create a 0 there. So what we're going to use as our pivot is our 5 in this position. And if you didn't remember we were using our 1 as a pivot when we went from this step here to here. Okay? Now, 5 is now our pivot. So we can go ahead and do that. So we're going to do 5 times row 1 minus row 2 to get a new row 1. And we're going to do 1/3 times row 3 to get a new row 3 because the terms in, or the coefficients in row 3 all have 3 in common. So we can change both of those. So our matrix is going to become 5, since we're doing 5 times row 1, so 5 times 1 minus 0, then that gives us 5 here. Then we're going to do 5 times 1 minus 5, that's going to give us a 0 here. Then we're going to have negative 3, and then we're going to have 350. Row 2 did not change, and it shouldn't because we're using that as our pivot. So we just write down what we had, and then we're going to multiply all of the terms in row 3 by 1/3. So that will simplify to 0, 0, 1, and 50. Now, we've created a 0 in the 1, 2 position and in the 3, 2 position. Now we're going to use this 1 in the 3, 3 position as our pivot, and we're going to change this negative 3 to a 0 and this 8 to a 0. So let's do it. Again, try to do it on your own. Pause it, see what calculations you need to do, and then row reduce. So we'll have row 1 plus 3 row 3 to get a new row 1, and then we're going to do row 2 minus 8 row 3 to get a new row 2. Performing those operations will give us the new row 1 of 5, 0, 0. And again, this 1 here is our pivot. So you have 5, 0, 0, 500. We have 0, 5, 0, 500. And then you have 0, 0, 1, 50. Now it's looking like it's almost in reduced row echelon form. The only thing we need to do is get this 5 to be a 1, that 5 to be a 1, but thankfully this 5 and 500, they have 5 in common, so we can multiply each row by 1/5, and then that'll make this 5 a 1. So similarly with row 2, so 1/5 times row 1 to get a new row 1, and then we're going to do 1/5 times row 2 to get a new row 2. That'll give us the matrix 1, 0, 0, 100, 0, 1, 0, 100, and 0, 0, 1, 50, which means it means x is equal to 100, y is equal to 100, and z equals 50. So that means x equals 100, y equals 100, z is equal to 50. So you purchased $100 shares of WSR, 100 shares of HCC, and 50 shares of SNDK. So you have to remember what your variables represent, and you have to remember what your ultimate question was. Okay, so there you go. Now let's do our final example. So, traffic flow. And traffic flow is a little bit tricky, but you'll have problems like that in your homework. So let's work through one to hopefully make that one in your homework a lot simpler, or more understandable. So let's read through it. The traffic through downtown East Podunk flows through the one-way system shown below. So the arrows here, notice that the 300 is going into A and it's exiting A through C and A through D, so it's flowing that way. And then traffic flows from C on Division Street. So notice that that's April Street. This is Division, and then it's flowing down there and it's flowing out at 300. And then from D, it's flowing on Embarkment. And then from C to D, that's Canal Street, and you have it at 100. Okay, so the traffic counters find that 300 vehicles enter town from the west each hour. So they enter town from the west each hour. Okay, and 300 leave town toward the east each hour. Okay, so they leave toward the east. Also, 100 cars drive down Canal Street each hour. So that's where that 100 came from. what we want to do is we have three parts to this question. A, we want to write down the general solution of the associated system of linear equations. And we want to answer the question, is it possible to determine the number of vehicles on each street per hour? So, in order to be able to write down the general solution of the associated system of linear equations, we first have to figure out what we know and what we don't know. It'll be helpful for us to label the streets because those are our unknowns. So we're going to let this one, April Street, this side here, we're going to let that be X. We're going to let this be Y. We're going to let this one be Z. And we're going to let this one be W. Okay? So when we talk about our intersections, at intersection A, we know that the traffic in equals the traffic out. So this is your traffic in. The traffic out goes on April Street and Canal Street. So that means the intersection A, we know that traffic in is traffic out. So that means 300, that's your traffic in, equals the sum of the traffic out. So that's X plus Z. Or if we're putting our variables on one side, you'll have X plus Z equals 300. At intersection B, same thing for each of these. Traffic in is the same thing as traffic out. So now we're looking at intersection B. So where is intersection B? You need to label it. So that's B. Okay, so traffic in is traffic out. So traffic in to intersection B is Y plus W. Traffic out is 300. So equation-wise, that is Y plus W equals 300. Notice that we have 4 variables. This is just thinking ahead. We have 4 variables. So here you're thinking we probably should have 4 equations, or we're hoping we do anyway. We will. Okay? So let's continue. Intersection C. Traffic in is traffic out. At intersection C, traffic in is traffic out. So traffic into intersection C, we have X. Traffic out of intersection C is 100 plus that Y. Okay, so you have X, that's your traffic in, is equal to your traffic out, which is 100 plus Y. Or putting all the variables on one side, we have X minus Y is equal to 100. That's just manipulating this same equation here. Okay, and now intersection D, again, traffic in is traffic out. Okay, so at intersection D, we have traffic in is the same thing as traffic out. So you would have Z plus 100 is W. Okay, so we have 100 plus Z is equal to W, or putting all the variables on one side, you have negative Z plus W is equal to 100. So our equations that we're using, this is 1, this is the next one, this is 1, and this is 1. So we have X here. So notice that there's an X here, no Y, which means your Y position will be 0. You have Z, so your coefficient is 1, and then there's no W, so you would have 0, and then your constant is 300. Similarly here, you would have x, there is none, so x would be 0. Y is, the coefficient is 1. Z, there is none, your coefficient is 0. W is 1. And then you have 300. So setting up our augmented matrix, we have the following. And I'll use red. Erase that. Our augmented matrix here is, and we're using all of those 4 equations. Right, a little bit larger. We have 1, 0, 1, 0, 300. We have 0, 1, 0, 1, 300. That's coming from this equation here. And then this one over here, we're going to have x is, the coefficient of x is 1, coefficient of y is -1. There's no z, there's no w, and then we have 100. And then the next one, there's no x, there's no y, coefficient of z is -1, and then you have the coefficient of w is 1 and 100. Now what we're going to do is we're going to row reduce, because it wants to know, is it possible to determine the number of vehicles on each street per hour? So we're going to find out. Okay, so just so you're aware, this is the x column, this is the y column, that's the z, that's the w. Okay, so let's row reduce. Looking at column 1, we already have zeros here and here. We just need one here. So let's just subtract the rows and get a new row 3. So row 3 minus row 1 to get a new row 3 gives us the following matrix. 1, 0, 1, 0, 300. Then we'll have 0, 1, 0, 1, 300. We'll have 0, -1, because we're subtracting it to get a new row 3. So 0, -1, -1, 0, and -200. And then our row 4 stay the same. So that's 0, 0, -1, 1, and 100. Okay, now so that was using this 1 here as our pivot. Now what we want to do is use this 1 as our pivot and create a 0 in this position. So to do that, what we're going to do, the row operation we need is row 3 plus row 2 to get a new row 3. That's going to give us the following matrix. 1, 0, 1, 0, 300. 0, 1, 0, 1, 300. 0, 0, -1, 1, 100. 0, 0, -1, 1, and 100. And then we can make an observation here. Row 3 and row 4 are the same. So if we add those rows, then we're going to get a row of zeros if we change this row, this 4th row. So we're going to do 2 operations. We are going to get a new row 1. You don't need to do that. So we're going to create a 0 in this position, a 0 here, and we're going to use this as our pivot. So the operations here, row 1 plus row 3 to get a new row 1, row 4 minus row 3 to get a new row 4. Performing those operations will give us the following rows: 1, 0, 0, 1, 400. That needs a little bit more space there, so 400 is in a different column. Then 0, 1, 0, 1, 300, 0, -1, nope, that's a 0, 0, 0, -1, 1 and 100. And then if you add row 4, or take row 4, subtract row 3 from it to get a new row 4, that gives you 0, 0, 0, 0, and zeros. So we have a row of zeros, which means one of those variables, particularly the variable that falls in this column, is going to be an arbitrary number, right? Because we have x is equal to w. This is in the w column. The coefficient is 1. So it's going to be w, or x plus w is going to be 400. So the translations, will be able to write all of those out. But first, let's go ahead and make this -1 here a positive. So let's go ahead and do that. So -1 times row 3 to get a new row 3 gives us the matrix 1, 0, 0, 1, 400. That's your matrix. Then the second row is 0, 1, 0, 1, 300. The third row is 0, 0, 1, -1, and then -100. And then the last row is all zeros. So translating this back into a system of equations, so translating into equations, we get the following system. Looking at the first row, this means we have 1x plus 1w equals 400. So we have x plus w equals 400. We have y, and from the second row, y plus w is equal to 300. From the third row, we have 0. Well, so we don't write a 0 there because that's 0. So from the third row, you see you have a 1 here. That column was z, so you have z minus w. Let's write that. So you have z minus w is equal to -100. And then w, because you have that row of zeros, w is arbitrary. So solving for x, so this is your system. So what this means is x is equal to 400 minus w, y is equal to 300 minus w, z is equal to -100 plus w, w is arbitrary. Since there are infinitely many solutions, it is not possible to determine the number of vehicles on each street per hour. And notice that w has to be greater than or equal to 100, but less than or equal to 300. Okay? Now we can go on to the other parts. Okay, so now the second part and the second and third part of the example. Let's answer these questions. So it says, on which street, there's no need to underline that, on which street could you put another traffic counter in order to determine the flow completely? On which street could you put another traffic counter in order to determine the flow completely? So measuring, you can look back at your diagrams, measuring the traffic flow on any of the streets April, Broadway, Division, or embankment will determine the answer. And that's the answer to this question. Okay. Part C. What is the minimum traffic flow along April Street consistent with the information given? So from the general solution in part A, from the general solution, you hear somebody whistling down the hallway. From the general solution in part A, the traffic flow along April Street is given by the equation x equals 400 minus w. Since the longest, or largest, not longest, since the largest possible value of w is 300, the smallest value of x is 400 minus 300. So we're plugging in 300 for w there. So 400 minus 300, which is equal to 100 vehicles per hour. Okay, and that's the solution there. And then what this note is at the bottom of the page, that just goes through calculating or reducing completely your matrix using the website www.waynermath.com, which is what we use through example 2 in class, or example 1 in class. So if you have questions about anything, write the questions down, come to class prepared for them. See you tomorrow. Bye.